this is a question where we need to make a finite state machine FSM for detecting a particular sequence. Here the sequence is 0 and we don't care what we get, either a 0 1. We can get either a 0 1 and it should end with 1. So we have 4 sequences that the FSM need to detect. These are the possibilities. Okay. Now uh, let's start by building this. Okay, so the first step is get a reset signal and make a base state. Now from this state, this is state where the FSM is eagerly waiting for the input. Now the first number in the sequence is 0. Okay, so 0, anything 1. Okay, so the state, if in the state S0, if it gets an input 0, then it will move to state S1. Okay, so state 1 S1 represents that it has matched 1 0. If it gets 1, remain in this state and go nowhere. Okay, so this is the only possibility. Yeah. Now from this state, it can either match a 0 or a 1. Okay, there are both possibilities. You can match a 0 or a 1. Okay, so there are two paths to be taken from here, that is either match a 0 or match a 1. Okay, now if it matches a 0, it will go to state S2. It will go to state S2. If it matches a 1, it will go to state S3. Now from here we have two more possibilities. If it matches a 0, it can either match 1 or a 0. Okay, so from here also there are two possibilities. It can match a 0 or match a 1. Similarly, from here also it can match a 0 or a 1. Okay, so this state S2 represents that we have matched 0 0, 2 zeros, and state S3 represents that we have matched 0 1. Okay, now we would assign separate states for all of these. Okay, state we will name it state S4, S5, S6 and S7. Okay, don't care about how many states you are getting, just focus on achieving the functionality. Then if there are redundant states, then we can easily identify them and get rid of them. But initially, while building FSM, you should concentrate on the functionality itself. So the state S4 represents that we have matched 3 zeros, 0 0 0. Okay, so this case, then we are only left with matching a 1. Okay, so if I get a 1, then move to somewhere else. Okay, so we would match, if I get a 1, we would match 0 0 1. Okay, so 3 0 0 1s, so we can go here. Okay, 0 0 1, and then if we get a 1, we can we are actually detecting overlapping sequences now, so we should be careful about where the next state is going after detecting a particular state. Okay, let me clear out this. Okay, so from state S4, it has matched 0 0 0. If it gets a 1, it would, to detect an overlapping sequence, it should go to a state where it matches 0 0 1. Okay, so what is the state where it matches 0 0 1? This is state S5. So if it gets a 1, go to state S5. If it gets a 1, go to state S5 where it matches 0 0 1. State S6 represents that it has matched 0 1 0. State S7 means it has matched 0 1 1. Okay, if it gets a 1, we match this. Now from state S5, if we get a 1, okay, we would complete the pattern and go to some other state. Which will that state be? We are matching 0 0 1 1. Okay, so the state it matches the upcoming the upcoming sequence that it should match is 0 1 1 1. Okay, so it should go to a state where it matches 0 1 1. What is that state? 0 1 1. So from S5, if it gets a 1, if go to S7 where it matches 0 1 1. Okay, now if you get 0 0 0, then go back loop around here. Okay, so you are state S4 is where you match three zeros. Okay, state S4 is where you match three zeros. Now again, if you get a 0, you will get the same pattern here. Then you get a 1, then it would detect this sequence. Okay, so if you get a 0 while being at the state S4, loop around itself. If you get a 1, go to S5. Okay, similar is the case with S5. uh, if you get a 1, go back to go to S7 to match the pattern 0 1 1 overlapping sequence. Okay, if it gets a 0 while in the state S5, what will get? 0 1 0 0 1. S5 matches the pattern 0 1 1. If it gets a 0, what would it match? 0 1 0. What is the state where it matches 0 1 0? 0 1 0, state S6. So if it gets a 0 when it is at state, then when the FSM is at state 5, go to state S6. Okay, now again we have done for this. Okay, now for state S6 matches 0 1 0. If it gets a 1, it would complete the pattern and go back to place where it matches. See, we want a sequence which starts with 0. Okay, so 1 is no use. This the pattern behind this 0 is of no use to us. So we would go to a state where it matches 0 1. What is the state where it matches 0 1? It is S3. So if you get 1 when you are in the state S6, go back to S3, because S3 is the state where it matches 0 1. Okay, you are to detect overlapping sequences now, so that is why. If you get a 1, go to S6. S3, when you are at state S6, you are matching 0 1 0. If you we got the state where it matches it goes to S3 when it finds a 1. Okay, if it gets a 0, it should go to a state where it matches two zeros, because this sequence is not any use of us. We are not detecting 0 1. Okay, we are starting from 0 0. So this is the pattern, overlapping pattern, which is of interest to us. Okay, so what is the state where it matches 0 0? State S2. So if it gets a 0, then go to, it is becoming a bit cumbersome, go to state S2. Okay, go to state S2 from S6 if it gets a 0. Now both possibilities are over. From state S7 is where it matches 0 1 1. If it gets a 1, we are matching 1 1 1 1. Okay, 1 1 1 1 is of no use to us. Okay, we would require to start from a 0. So if it gets a 1 while in the state S7, go back to S0 to match a 0 again. You have to start from the starting again, because this is no patterns being matched from the previous overlapping pattern is not there. No overlapping pattern is matched. Okay, if you get a 1, go back to S0. If it gets a 0, that is 0 1 1, it would not trigger the output, but 0 1 0. Okay, 0 1 1 0 is also, see, the only thing that is being matched or overlapping is this 0. So it would go to S1 where it detects a single 0, because that is the only thing that is being matched if it gets a 0. Now okay, so for this I have done both 1 and 0. So for every state you need to check that what will happen if you get a 0, what will happen if you get a 1. So for state S0 it's okay, for state S1 0 1, for state S2 also there are defined, for state S4 S5 S6 and S7 those are defined. So the FSM is complete, and now we will go about writing the output equations. When will the output be asserted high? Okay, it will be asserted high whenever S4 and we get whenever the FSM is in S4 and we get a high input high. Okay, so dn is if you don't understand, let's assume the FSM to be like this. It is our FSM, we are giving a serial data input d in, and the output is being observed here. So FSM is our black box. It reacts to whatever inputs we give serially. So okay, for every clock pulse or every rising edge, it detects whatever the input sequence is there. Okay, then acts accordingly to our design. So the output equation would be, okay, so the output will be asserted high whenever we are in the state S4 and we get the input high, or whenever we are in the state S5 and get input high, S5 times D in. Okay, whenever we are in S6 and we get an input high, it would match this sequence. S4 in for S4 D in, it would match this pattern. For S5 D in, it would match this pattern. For S6 D in, it would match this pattern. For S7 D in, it would match this pattern. Okay, plus S6 D in, okay, plus S7 D in. So concise output equation would be S4 plus S5 plus S6 plus S7 times D in. This is the output equation. So if you want design equations, you can easily do that. Okay, so this is the output equation. For design equations, you need to see how many states are there and then act accordingly, and while to choose the number of flip-flops you need. So we have total 8 states. So 8 states, 3 flip-flops would be enough, because 2 power 3 is 8. We would get 8 states here. Okay, so we have 8 states including S0. Okay, so to get those, we would name each state, we would number each state. Okay, so let's assume this S0 is 0 0 0, S1 is 0 0 1, S2 is 0 1 0, S3 is 0 1 1, S4 is 0 0 1 0 0, S5 is 1 0 1, S6 is 1 1 0, S7 is 1 1 1. Okay, now for design equations, okay, so these three are D0, D1 and D2, D2 being the MSB, D0 being the LSB. Okay, so we need to derive the next state and previous state in logics. For see, in practicality, we would have 3 flip-flops, 3D flip-flops. Okay, D3, D2 and D2, D1 and D0. We have 3 flip-flops, D0. Okay, and it would output Q2, Q1 and Q0. Okay, so the D0, D1 and D2 should have a next state logic input. The combinational logic should be there, should be present to determine the next state according to the FSM. So for D1, for D0, I'll write the design equations for D0, and you can write the design equations for D1 and D2 by the okay, the same method. Okay, for D0, where are the states where D0 is getting high? State S7. Okay, S7, state S7, then state S5, then state S3, then state S1. So these are the states, and what are the incoming inputs to that states? Okay, for S7, what are the incoming arrows? Incoming arrows are S3 times D in plus S5 times D in. For state S5, what are the incoming arrows? S2 times D in. For state S5, S2 times D in and S4 times D in. For state S3, what are the incoming arrows? There are 2 arrows, S6 times D in and S1 times D in. For the state S1, what are the incoming arrows? Only one. There are 2 arrows. Okay, there are 2 arrows which are S7 times S7 times this is actually 0. So S7 times D in bar and S0 times D in bar. So those are the design equations, and you can subsequently write the design equations for D1 and D2. Okay, thank you.